Oh, hey guys. This is topic 1.7 or 1-7, however you want to, I don't know, however you want to refer to it. Doesn't particularly matter to me which way you refer to it. We're finishing off the rules for exponents today. So today we're going to talk about the zero exponent property and the negative exponent property. Okay. So yeah. We have Marcella. She's playing a card matching game with some classmates. 4 matches have already been made. 3 to the 4th matches to 81. 3 squared is 9, right? 3 times 3 gets you to 9. 3 cubed, 3 times 3 times 3 is 27. And then 3 to the power of 1, well, that means there's just one 3, so that's a 3. So 4 matches have already been made. Excuse me. It is Marcella's turn, and she chooses 3 to the power of 0. I think that's the zero exponent property we're talking about. What card would complete her match? So if we take a look at this, and let's get this here, right? How do I want to do this? My giant head's in the way. Okay, so we have this table representing kind of these cards, right? 3 to the 4th gives us 81, 3 cubed gives us 27, 3 squared gives us 9, right? And so we can kind of take a look at the pattern that's happening here, right? We have this 81, we reduce our kind of exponents by 1, which means we're getting rid of a 3, which means technically we are dividing by a 3 to get to 27, right? As it goes down this way. And then 27 to 9 is the same thing, right? We divide by 3 to get from 27 to 9. Divide by 3, sorry. And then we're going to divide by 3 again for that pattern, right? Which will give us 3, right? So 3 to the first is 3, just like that. And if we continue our pattern right here, where we have this 3 to 0, where we take the previous number and then divide by 3, we end up getting 1. So the simplified form of 3 to the power of 0 is 1. So the card that she would match with that 3 to the 0 is 1. And that brings us to our zero exponent property, where we say any exponent, and this is the easiest rule by far, any exponent to the power of 0, power of 0 is 1. So yeah, that's that. Whenever you see a 0 exponent, you just make that part of it 1. That's it. So if we look down here, -7 to the power of 0, I don't really care what's inside the parentheses because it's to the power of 0. So that gives us 1. 43, it could be a million for all I care. It's still going to be 1. 1 to the power of 0, well, look at that. It's still 1. It gets a little more complicated when you have something that is not to the power of 0, because this 0 exponent only applies to the 7, not to the 2. So what happens here to make this equal to 2 is you have 2, and then this happens inside the parentheses, right? Just like PEMDAS with our order of operations, parentheses or grouping symbols come first. That 7 to the power of 0 becomes 1, and then 2 times 1 gives you 2. That's why, because 7 to the power of 0 becomes 1, and then 2 times 1 is 2. I don't know what more else to say, because that's just the easiest one, right? It gets a little more complicated. This is the negative exponent property. Okay, so we have this expression right here. We have this 4 cubed divided by 4 to the 5th. Now, we're going to use the quotient rule for this, which means you keep the base the same and subtract your exponents when you're dividing exponents to the same base. Right? So 4 cubed divided by 4 to the 5th, we say 4 to the 3 minus 5 gives us 4 to the -2. That's weird. I have not, or I have, but you guys haven't necessarily seen that yet, right? So I have this 4 to the power of -2. And the thing is, we don't want any negative exponents in our answers, right? So you'll often see it say using positive exponents, right? So if you have a negative exponent, that's not your final answer. You want to make it so it has a positive exponent. And there's a couple ways we can approach this here. I'm just going to give you the rule. All right. So for a negative exponent, you flip the number to the other side of the fraction, and then change the negative to a positive. Okay, so flip the number to the other side of the fraction, right? So technically, right, there's a 1 right there, right? You can make anything into a fraction by putting it over 1. So you, boom, flip it around, so it becomes 1 over, and as you flip it, you change the negative to a positive, 1 over 4 squared. 4 squared is 16, right? 4 times 4. So you could simplify it a little bit to be 1 over 16. Either way, I'm fine with leaving it as an exponential expression. Another way to think about this, right? You have this 4 cubed divided by 4 to the 5th. Well, we can just kind of put this in expanded form, right? 4 by 4 by 4 on top, and then 4 by 4 by 4 by 4 by 4 on the bottom. Cancel all those out, and you're left with basically just 1 on top, just like that. And then you have 2 4s on the bottom, right? So it's the same exact thing. It's a different way to get there, or a different way to think about it, really. But yeah, the whole idea here is whenever you see a negative exponent, you're gonna flip it to the other side of the fraction. And then if you see something like this, where it's, I don't know, x over y to the negative 3, right? Even if it's on the bottom of the fraction, you just flip it to the other side, right? So this y to the negative 3 would stay up here. You change the negative to a positive, this would become x y cubed, right? So if it's on the bottom and it's a negative, if it's on the bottom and it's a negative, you move it up to the top. If it's a negative and on the top, you move it down to the bottom. And as you move it, you change the negative to a positive. That's it, okay? So this is 1 over 8 squared. Once we shift it down to the bottom and get rid of the negative, this is 1 over 2 to the 4th, and this is 1 over 3 to the 5th, right? Not super crazy. It gets, boom, we already talked about this. So yeah, when it's on the bottom, you do the same thing, right? You just flip it up to the top. So this just becomes 7 cubed. 1 times 7 cubed is the same thing as 7 cubed, so 7 cubed. Well, that's a really easy example. Yeah, shoot. I don't know. Okay. So write each expression using positive exponents again. You just kind of shift it to the other side. This just becomes 5 cubed, which we know that's 125, right? And as you flip this around, it just becomes 2 to the power of 6, which 64 maybe? Anyway, yeah, I don't know. Flip it to the other side of the fraction, change the negative to a positive, right? And if something doesn't have a negative exponent, you just leave it where it is, okay? So if this x is on top with no negative, you leave it on top. If it's on the bottom, you leave it as well. So if I have something that's, a little more crazy, right? Like x, y to the power of negative 3, and then z to the negative 7, right? What's going to happen is that this y to the negative 3, this z to the negative 7 are going to flip-flop, but this x is going to stay where it is, right? And actually, let's say I have like something like 7. That's a weird-looking 7. Sorry about that. 7z to the negative 7. I'm consistent with my 7s here. Again, this 7 has a negative, has a 1, like just a regular 1, positive 1 for it. So it doesn't move at all, right? This negative 7 does not apply to this positive 7. So the x and the 7 are going to stay where they are. The z moves to the top and becomes positive. That y moves to the bottom, becomes positive. And that x and 7 stay where they are, right? That's our little answer for that example. So yeah, just be aware of that. If it doesn't have a negative exponent, it stays where it is. It doesn't move around, okay? Yeah, okay. So this is the concept right here, guys, right? If it's to the power of 0, it becomes 1. If it has a negative exponent, you flip it to the other side of the fraction and change the negative exponent to a positive exponent, right? I don't care what this number is. If it's to the power of 0, it is just 1. You flip it to the other side of the fraction, just like so. Okay. Flip it to the other side of the fraction, change the sign. Okay. And this is kind of what we're talking about. We have a combination of rules happening here, right? So we have x to the power of 4, and then y to the power of 3. So let's, and this is evaluate, meaning we're not going to leave it as an exponential expression. We're actually going to figure out the value for this. We're going to leave it in simplified form, I believe is what it's called. Yeah, right here, simplified form. Make it actually a number, right? And get rid of all those exponents. Like actually do the work, right? Put the work in. So if I kind of like plug this stuff in, right, that 4 is going to go in place of the x, and that 3 is going to go in place of the y. Okay, so we can approach this a couple ways. We can do kind of the exponent rules first and then plug our stuff in, or we can plug our stuff in and then do the exponent rules. It doesn't matter. I guess I'll show you both ways. If we do the exponent rules first, this x to the power of 0 becomes 1, and this y squared moves to the bottom. So it becomes 27 over y squared. Right? If we do the exponent rules before we plug in our numbers, right? That x to the power of 0 is 1, so 27 times 1 is just 27. And then you plug in that 3, so it's 27 over 3 squared, which is 27 over 9, which is 3. Okay, so you can do that, or you can plug them in first. So it becomes 27 times 4 to the power of 0 times 3 to the negative 2. Okay, and so then what happens right here? This 4 to the power of 0 becomes 1. This 3 to the negative 2 moves to the bottom to become 3 squared, which that's that step right there, right? Same way, right? So it's 27 divided by 9 gets you to an answer of 3. So you can approach that either way. It's going to work out. It's all going to be okay, guys. Okay. So fold this guy in half. Hamburger style. El estilo de hamburguesa. Oh, I'm running out of glue. Uh-oh. Sorry, guys. I had to go get some glue. This is page 13. This is 1-7. More properties of exponents. So I'm just going to say exponents. It's a weird looking E. Sorry about that. Yeah, I can see you guys are complaining about the glue. It's fading fast. Okay. Let's see. More properties of exponents. Page 13. All right, so that's 1-7. More properties of exponents. And yeah. Okay, I'm gonna zoom out. That's it. Okay, guys. Yeah.